Hello and welcome to my shed. Today we're going to talk about the basics of muscles, how they work and how to remember some of their attachments and their functions as well. So we'll first of all talk about how they actually contract. Well, firstly, muscles work by contracting. All they're doing is shortening their length and bringing 2 points together. Let's have a look at the biology of that in a bit closer detail. And to do that, I've made a model of the sarcomere, which you may remember from A-level biology. So here's my model of the sarcomere. We have actin and myosin filaments within the sarcomere, and these can slide within each other. With the action of calcium and ATPase, we get lots of cross-linking between the actin and myosin the myosin filaments are pulled along the actin filaments, so that you get contraction of your muscle. If you remember, lots of these actin and myosin filaments are all stacked together along the length of the muscle, so the overall contraction and shortening occurs. Without the action of the calcium and the ATPase, the sarcomere can stretch because the cross-linkings between the actin and myosin filaments relax. So we've seen all those sarcomeres shorten. In a muscle, you've got lots of sarcomeres all stacked up along the length of it. Hence we call it striated muscle, because down the microscope they look a bit stripy. So it gives the muscles two properties. One, they're very powerful, but it means they can't shorten huge distances. For a muscle to move a joint, it's got to be attached to bone either side of that joint. But remember, the property of the muscle is that it can't shorten huge distances. There's certain specific things about where it attaches either side of the joint which make it mean it can optimize how much it's moving. So why don't we illustrate that on the human skeleton? Most of us keep one or two of these in our closets. So on this skeleton, I've put some bony attachments. You can see these hooks in the forearm. I'll put one up near the shoulder. We've said that biceps bends the elbow. So this muscle has to be on the front surface of that joint, and it's got to have bony attachments either side of the joint. Let's represent our biceps with this rope. We've got a bony attachment up here near the shoulder, and we'll patch another bony attachment down here near the wrist. We'll see, with the muscle contracting and shortening, and we'll represent that by pulling on the rope. Great. We've shortened the muscle, we've brought those two attachments together, and the elbow has flexed. However, look at how much length that muscle has had to shorten itself in order to get that movement. You'll also note that this muscle goes from here straight across to the forearm. Now, we haven't got lots of webbing on us, and when you see me bend my elbow up, the muscle's not going across like that. So clearly this isn't going to work. It's quite nice mechanically because it's fairly easy to pull that up, but muscles can't shorten that much and they don't have that much skin covering them to allow that webbing. Let's think about the properties of muscle again. They're very powerful, so we don't need that mechanical advantage, but they also can't shorten a huge distance. Let's move the attachment of this muscle from the forearm to much closer to the joint right by the elbow here. So we're going to do the same thing and shorten the muscle, and we've got exactly the same movement but with a much shorter amount of shortening of the muscle. So the muscle hasn't had to contract nearly so much to get the same movement of the elbow. Admittedly, it was a little bit harder to pull on the rope there, but we said our muscles are powerful. So a really good way of remembering where the attachments of various muscles are is that the principle is one of the attachments has to be some distance away from the joint which is being moved, because we need that nice long muscle for all those sarcomeres to be stacked up along it. But we also need the other attachment very close to the joint, so the muscle doesn't have to move very much in order for it to work. And biceps brachii is a good example of that. If you can remember that principle, you'll find it easy to remember the attachments of the muscles. Thanks very much. I better put my friend back in the closet. Cheerio.